Our next speaker is a web team lead at daily.dev. Oh, and he also completed the amazing challenge of publishing blog posts every single day for 1,000 days. Discussing microservices optimization, here is Chris Bongers.
Cool. So yeah, thank you for having me. As mentioned, I'll be talking about microservices and yeah, what they are, kind of the pros and cons to the system. And I'll hope you enjoy the talk. Feel free to ask any questions at the end. I will start sharing my screen. There we go. Cool. So yeah, the talk today is about designing for scale, optimizing microservices. It's mainly a good introduction into what they actually are, and yeah, let's get started with that. So first of all, let me introduce myself to you all. I'm Chris. I'm a proud husband. Been married for 2 years now. We have a very cute little rescue dog. You can see her there in the picture. Absolutely love her. She goes on all the trips with us, which is amazing. And I'm really excited that we also have a baby on the way. So yeah, that's something I'm really looking forward to, becoming a dad, and all the challenges that come with that. So definitely a cool thing to look out for. Yeah, as mentioned, in my day-to-day job, I am the web team lead at daily.dev, which is a really cool tool for developers. Brings you the latest news. If you don't know about it, go check it out. I'm a big fan of the digital nomad life, but I always say it with a little bit of salt and pepper because I do like to travel. I'm originally from the Netherlands. My wife is from South Africa. We live a little bit all over the place. So every now and then we go to different places to stay there for a couple months and enjoy the vast amounts of wonderful places in the world. With obviously remote work, it's very possible. So I'm blessed to be able to do that. I used to be a daily blogger. I actually wrote technical articles every single day for over 1,000 days, which was a really cool challenge to do. Met a lot of cool people, wrote about a lot of interesting things. And yeah, I really think it helped me to express, being a developer again. Even though like I develop a lot in my day-to-day job, you feel sometimes you can't explore certain aspects because you just don't use the language or whatever it may be. So yeah, I learned a lot from blogging, and I do have something planned for a next challenge. So that's something to keep an eye out for. And when I'm not doing any of those things, I'm a big fan of hiking. So me and my wife and the dog, we go hiking a lot. Obviously, a lot of mountains in South Africa, so it's our weekend activity. And obviously, love good food. Yeah, that's about me. Let's get started on the presentation. Right. Whoa, sorry for that. I think I messed up the order. So before we go into microservices, let's take a look at like kind of what you hear a lot. If you hear microservices, you will hear monolithic architecture. I mentioned here, is it an era in the past? But first, let me explain to you what it is. So I remember when I started, developing many years ago, talking about like almost 20 years now. Yeah, there was like a way of developing applications, and it was basically creating one big file space with all your things in it, right? So I actually started as a PHP developer, so you would have your one code base. It did basically everything. User management, it did uploads, it did whatever you needed it to do, and it was one big file, often with a single database attached to it. And that was it. It was perfectly fine until we started looking at like, okay, there are some drawbacks, right? So the first is language and framework. We were obviously bound to use a singular language often. You could obviously mix it up, but it was very hard and frustrating. You definitely had issues combining frameworks into one system. And why it became more and more important is because we realized over time there are the right tools for a specific job. So when you do data analysis, you might want to use Python. When you do front end stuff, you might want to choose React as your framework, or Vue or Angular, whatever is your poison, and so on. If you want to do some background work, you might want to use Go or whatever it is you find works for you. So that's one of the drawbacks with monolithic. It was very hard to do. The second one I want to mention is growth. So considering you now have this massive code base, everything is kind of intertwined, right? So your database is one big monster. It does everything all at once, and you want to change something here, it affects other tools, other systems, other models. So it just slows down your development speed, really, and in terms of your growth. And we'll get to the pros of microservice in a bit, but another one is obviously slow deployments. You have your one deployment that could take forever if you set up the system in a certain way. It just takes a while to either compile your application, whatever you're using, or simply deploying it just because of the size. And the last one is something, I don't know, nowadays modern development is very important, obviously, to be fast for end users. So scaling became very important, like to don't overuse resources. I'm sure some of you might remember, the good old days where you had your own self-hosted server rack in companies, and the thing was just overcomplicated, overspec just in case you needed it. Nowadays, obviously, with cloud, it's very easy to get the exact right server for your application. It can kind of scale with you. But still, if you host a monolithic system on the cloud, you're often overusing, because one part of your application might be needing resources, while the others are really okay with not having that many resources. So in short, a monolithic, it's a massive beast. I kind of try to paint it here as one big block, which does kind of everything. It can obviously have multiple things inside of it, but it's all twined into one code base. And that kind of brings us to microservices. So what exactly are these microservices we talk about? And to be very brief, they are basically small independent systems that contribute to the bigger system. So I kind of painted it here as a Tetris, no, not Tetris, Rubik's Cube, sorry. And why I do that is because it makes up one system, but they're all individual pockets, right? So you can technically take them all apart, and they have their own function. They don't disintegrate, obviously, but if you put them together, that's what really makes them work together. So yeah, so what are like some of the high level things that we can look at when we talk about microservices is we'll go into detail into each and every one of these, but basically high level, each service can have its own technology stack, its own database and models, including own language, right? So you can pick the right language. They can communicate to each other, often over an API, or event streaming, message brokers, kind of depend what system you choose. And they are often organized by business logic, right? So the services are often bound to a specific context, which is good to know. Some examples, because it might be hard to put it into place, is you could think maybe user management can be one system. content can be one system. What else do we got? We got files, maybe one system, and so on. You can have some background workers. You can have analytics as a service. So basically, all kinds of services that get combined into one. The good thing to note is it's not something you have to develop, right? So obviously, very popular these days is this kind of like infrastructure as a service thing. So user management. There's tons of great options out there. FileStack, great example for all your file needs, and they can all kind of combine by being really developer focused. Like they kind of take away all the hard work for developers into making it easy for you to have an independent system that does exactly what you need it to do, which is a great add-on. Yeah, so with that, let's go look at some of the individual, pros and cons for everything. So the first one I want to touch upon is development speed. I mentioned here it's slow and fast, but it is coordinated. Why I say that is, imagine you have this monolithic versus microservices, right? Monolithic is generally slower because you need to often work on multiple aspects of the system. So overall, it's slower. But with microservices, you have your very independent small systems. So imagine you join a company and they are on a microservice. You often get introduced to one part of the code. Like, okay, today we're going to introduce you this part. You're going to be responsible for that in the first couple of weeks, right? So you really get to know user management, maybe the user microservice, which is great because it's a small system, you know it in and out, and over time you can slowly start learning the other systems, and that often helps with development speed. You don't have to know about the whole massive amount of microservices. You don't need to know about certain, analytics. None of your business in most cases, unless defined otherwise. But it really helps to improve your development speed to, grow the product as a whole. Yeah. And the second thing is that that also makes it easier to understand often. So because we are very independent with our services, we know exactly, okay, user microservice is for users. So you don't have to look at a big code base and find where exactly do we update the user's bio, right? Like it could happen here, it could happen there. With microservices, you ensure that there is one truth of source for that specific data set. In this case, let's take users for example. That's where it handles for. Other services might call an API, but you define what that API, what kind of format it needs, what data it expects, what's required, what's not. So it becomes way easier to understand the individual services. We'll get to the drawbacks as well, because I can probably envision you might think like, oh, but what about this? So we'll definitely get to those as well. But overall, it becomes way easier to understand the individual things. And especially, again, if we plug in that we can easily use external systems, right? So often they take away all the hard work that we tend to do, right? So like we introduce users, but if we use an external system, we might choose to have roles already enabled in the system. It's just a toggle you turn on and off. Tags is something you turn on and off. So with those kind of things, it becomes just way easier to understand instead of you rolling it all out as you go. And then this one I find probably the biggest advantage for microservices is tools that work. So it's about finding the right tool for the right job, right? So as mentioned, as a drawback of monolithic often is that you can have multiple systems that do very specific things, right? So for instance, you have a small analytics component that does a lot of background processing into data sets, reporting, whatever it may be. And you can choose a system that really thrives on that, right? So you can use a language that's really good at doing that, and so on. And you know, if you have some background systems, you might use fast languages as Go. And if you have more user-facing interaction, you can obviously use React, Angular, Vue. Like mentioned, data analysis might be using Python, and we can, you know, go on until the end of dawn. But the same can actually be said for user-facing components, as an example, right? So for certain parts of your application, you might say, oh, this is something that React is really good at, right? So you might want to use React for that. For another component, you might see, oh, well, this actually something Angular would be better at, or something in Angular that works better for that, and go for that kind of road. So even within the front end, you could go for multiple microservices for specific things. You often see this in, let's say, the admin side, the admin panel being a different architecture than the actual front end, the app or whatever, and then the mobile app being another one. So obviously they all have different applications or languages or frameworks that do a better job at that. So I think that's really a cool part, instead of us trying to fit it all into one box. And obviously it all has to contribute to the end goal of serving the best architecture for the whole system. Another thing I didn't really touch upon, but is very important, is databases, right? So some databases are just better at certain things, right? So analytics, you might want to choose a big data kind of database, and user-facing ones, you might choose like something else. You might choose like a NoSQL kind of system, or a MySQL kind of system, depending on what your needs are. So with this kind of thing, you can really choose to find, every system can have its own best practice. You know, some might use Redis on top of it, some might not, and so on. And to me, yeah, that's really cool. It also, this is actually also a really cool addition to this. For instance, I'm sure many of you have experiences. The company you work for, they might have built a system in Angular 1, whatever, many years ago, and everyone knows it's kind of outdated, but you know, it's too big. You can't just move it over. So what's really cool is that now you can kind of spool up your second microservice, and it can just take over one little part. So maybe it just takes over the login page, and you can build it in, you know, whatever is the latest Angular, React, Vue. You can give it a try, and you can even experiment. So we'll come back to that in a little bit later. But that's another really good advantage of microservices, just quicker proof of concepts to test things out and to try them out. By the way, all the images are generated by an AI, which it took me a lot of prompts to get the right things. So a really big part of designing microservices is actually scaling. So and to be very precise, efficient scaling is so important. So with monolithic, you really didn't have a choice. You have one system and you have to scale the whole thing, either horizontal or vertically, whatever it may be, but you had to scale the whole thing. You couldn't say, oh, only the user piece needs to be bigger. Only the file upload needs to be bigger. Only analytics need to have a bigger database. And it was quite harsh, you know. It cost a lot of money. A lot of resources go to waste because you actually didn't use it, or you potentially didn't need to use it. So yeah, with microservices, we can really say, okay, let's scale up this particular piece. So for instance, if you do analysis every night only, right? So you obviously pick some off-peak times. to do big data analysis, you can then say, okay, automatically scale up whatever you need, but none of the existing systems will be targeted towards that. The same goes kind of with efficient scaling in user-facing regions, right? So all your background workers can be on a cost-efficient server, where all the front-end face, so the user-facing things, can be on multiple servers across the world to make sure we serve the fastest possible front-end to each user, which is a really big pro in terms of being efficient for the user but cutting down on costs. So it's very important to note. And another big thing with this type of scaling and microservice architecture is, imagine we deploy something. Deployment is obviously faster, but now we introduce a bug, and the bug only lives in a certain type of the analytics tracking, right? But it's a pretty big bug, crashes some parts of the system. If that was monolithic, your whole server might potentially have gone down because it's all one big code base. Whereas now maybe our analytics service is down, which obviously it's not ideal. We want to work against that, but it's at least isolated, right? We can quickly redeploy, we can quickly fix it. It didn't affect the whole wide system, so users were still able to use the app, and so on. So I think another big advantage of why it makes a lot of sense. And then we get to testing. I briefly touched upon it, but yeah, the structure of microservice architecture makes it really easy to adapt a new language or framework. So we don't fully have to migrate, right? Imagine everything was written in PHP, and we kind of realized like, we can find some better tools for the job. jQuery no longer exists. We need to go to React, whatever it may be. Yeah, now we can. And we can slowly get there, which is the really cool part. As mentioned, it sounds really hard, but it's actually not. So we at Daily Dev often try out some things as well. We want to try out something, but we're unsure if that's the right way to do it. We can quickly spool up a system to try out a singular page, because obviously with cloud architecture, it's very easy to show people a different page. You have some really cool tools for that, and we can try if that works better than what we had before. The same goes for more of the backend work, right? So we have a lot of systems that are running in the background to deliver a perfect feed for people. So sometimes we want to run it in Go, and we might want to experiment with some external third-party applications that say they're really good at that. So okay, let's give it a go. We say 10% of our users can get this part, 10% can get this, and the other will get whatever we already have, which makes it really cool in terms of that. So even I forgot to mention that with scaling, but we can obviously choose which people get to see which deployed application if you set up a really good architecture. Architecture for Thingy being obviously a little bit harder for microservices, but overall, testing is such a great way to leverage the advantage of microservices, either being completely new apps or to test it out to a subset. Then we get to the point of frameworks, and frameworks are everywhere, especially in modern day development. I really can't keep up with what's coming out. You see a couple frameworks here in the background. It's a little bit outdated. Nowadays, yeah, we have tons of applications we can use. And yeah, so as mentioned in testing, sometimes it's great to try out a completely new framework on a little subset, just small proof of concept, try how it works. If not, we forget about it, delete it, and it's gone. But maybe it's really good, and we want to work on that as a future thing. but it can also be seen as a negative, right? So you might find all the microservices. Like, so imagine you work for a company. Over time, we have 10 different microservices, and each team decided to go with a different language, right? And each team might even be individual people. So someone might have been responsible for users. They decided to build it in Rails, where someone else was doing reporting. They built a Laravel application. There's nothing wrong with it if it works. But what happens if this one person that was responsible for the users now stops working for the company, right? They move on to a different company. So now you're stuck with all these frameworks, and maybe no one else knows how to pick them up. So there are some cons to really think about when it comes to picking the right job for what's around. So what you often see is that the CTO or more technical leads or solution architects, companies that have different people responsible for that, they try to keep track of what you're using and try to limit or reuse what's already there. So meaning that they might have a small little framework that they initially set up in a specific language that does all the heavy lifting, and teams can use that to build new tools on. So it's definitely something to keep in mind, and to not overuse. So don't start throwing all kinds of applications in the mix, because it can come back to bite you in the end. I think you should really limit to what you as a company as a whole feel, okay, this is still responsible. So obviously we can move to new frameworks if we want to try adoption, but if it doesn't work, you can always fall back. Just give me 1 second, I'll have a sip of water before we move on. All right. And another thing that is actually really good to mention when it comes to microservices, which is also quite a big impact. So I mentioned before, one of the pros is that people can quickly adapt each of the microservices, right? So it's very easy to get used to only the user base, only this part, only the analytics, only the backend side reporting. But it may become very, very difficult for people, especially onboarding new people, to see the whole big picture, right? So you might be responsible for the user base and say, no, everything's fine, my system works, my tests are running, but someone else might be dependent on your system, and now you've changed the email to no longer be mandatory, but their system relies on having an email because they send reporting emails. So things like that become very, very difficult, whereas with your monolithic thing, the whole thing would crash if that happened, right? You would know about it. So with microservices, it becomes very important to be aligned as a company on what you guys are building and how you're structuring everything. So even though each microservice will have its own data set and structure, one of the biggest things to do is to align that the company is using these things in the right way. So with microservice architecture, you often see that you get a little bit more meetings around like data and how are we going to set this up. It needs some more initial thinking rather than let's just build it. Not saying that that's always the case, though. Often happens either way. So it's just good to be aligned and to have some protocols in place to make sure. There are various frameworks to help you with this to make sure microservice architecture happens in the right ways. It's definitely something to keep track of. Yeah, and what's also very important here is it's not only that you might not know how the broad system works, right? So even taking daily dev again as an example, there are very many things I don't even know, like sometimes even that they exist, maybe, right? So like some team might have decided to introduce yet another microservice that helps their little microservice, and we might not know about it. So it also becomes very complicated to understand where data goes, who uses the data. So you might get requests saying like, oh, I used to do this before, but it no longer works. Have you guys changed anything? So bug hunting becomes pretty interesting at best. So it's good always to have perfect logging in place, monitoring in place when you start, scaling up a microservice. Okay. So let's go on to the next slide, and that's one of my favorite parts is some examples, right? Because you're obviously chatting a lot about like the pros and cons and what you expect, what it looks like, but what are some examples of microservice in the wild? And I think one of the easy ones to mention is obviously any big application these days is a microservice. Let's take YouTube for example. So imagine if YouTube wasn't the microservice, right? So now you all wanting to watch a webinar or a video or even a short these days on YouTube, you start and the streaming slows down. Like, what happened? Why is this so slow? And it's because someone decided to upload a video, which obviously takes a lot of resources. So you are now affected by that. And it costs YouTube a ton because they now have to scale up the whole thing to keep up with demand because people want to watch and they want to watch it quick. They don't want lag on their video. So it becomes an expensive hobby. So what they do is they abstract everything. So what you see is that the video players are microservices, the upload system is a microservice, the whole analytics behind it is multiple microservices, and even the shorts they abstracted as another microservice. Yeah, so each of these systems has their own strengths and protocols, right? So they obviously choose certain types of frameworks to serve specific things. And what's even better is because these are microservices, they can say, okay, Chris is in South Africa. We have a server right there. Let's just deploy an instance close to him so he has direct access. He can view the video in a specific format that works for his connection, which might not be the best. So we'll show him in a different rate, things like that. And it works. So that's really great to see. And this architecture you'll see with many of the big things. So Twitter, for example, they abstract a lot into microservices. They also write a lot of articles about that. So if you're interested in that, they have it on their tech blog, which is cool to see. Same with Airbnb. And what you often see is that they abstract a lot of the things into microservices as what's a business logic and what can we abstract. So that's often the cue to where you can cut it. And we'll get into a little bit more detail on that now, like where do you actually start? All right, so let's go to how to start. This is probably what most people, if you haven't really adopted a microservice yet, it'll be the biggest question on your mind, right? So like, okay, but like, yeah, all fun and games, but like, I'm lost. Where do I start? Like my system either exists or I've yet to start. And what you see is that most applications, even this day, they still start off as monolithic. And over time, you will find things that are like bloating, becoming difficult, and that's when you start to realize, like, okay, we can actually abstract this and make it a known project, or use an external third-party service. And that's when you start to think about designing for scale. So with that said, a good example obviously would be FastTag again. It does all the heavy lifting for you. Like we need an upload, but we don't want to build another microservice. So you start looking at what tools are out there that can help me. And you find in modern ecosystem of web development that there are many tools that do exactly what you want. So yeah, why would you want to reinvent the wheel again, right? So often authentication has a lot of things that are already there. Analytics has a lot of systems already there. Eventually, you might find yourself wanting to need something that doesn't do exactly what you want. So you can always go back to redesigning a microservice again. But especially a lot of the modern day applications use a lot of systems that are already existing, which is a great thing. So you can get exactly what you need. You don't need to think about scaling because they will all do all the heavy lifting for you. Yeah, but to go back to how do you start is you need to design things in an abstract way so that you can go further and further beyond what you envision, right? So this is very important and probably the most difficult thing about designing architectures for microservices. So what often happens is we have an existing system, we have an existing database. Now we need to start thinking about abstracting things. And what's very difficult there is that things might have been intertwined, right? So our user database might have had specific columns called article ID, which would be the top article for that user, whatever. If we redesign that, we can't actually rely on that kind of stuff. So our user database is only responsible for users. It does not know anything about articles. What are these things? I don't need to know, and so on. So you start to really think, okay, how can we set it up, and how can we improve that over time? So I do think that's one of the best things to keep in mind, is to design for the future. And with the future, it can be tomorrow, it can be next week, but start looking at like, okay, what about next year? What will the app look like? How big will it be? What will need to support? This is what I said before. You will have a lot more discussions with the whole team as to where you want to grow. And as I said, it's good to draw out an abstract data structure, and with that, data flows, which they become very important. So not only to design your system, but how does it interact with other systems? What do they need from you? Because when we talk about microservices, it often includes an API to pass data, but it also includes event streams, because a lot more will happen via events. So let's say a new user created, event gets fired, they get a certain role, they get a certain email, they get a push notification, they get reminders, they get reports, they get access to things. So a lot of things happen on different microservices almost at the same time, but that can happen off one event. So we can publish one event, we got a new user, certain microservices can subscribe to that event, and if they receive it, they know exactly, okay, I'm receiving a user which has an ID, an email, a this, a that. So that means that all your teams need to be aware of that and need to be aligned. What they need, what you need to send, and what they can expect, how it looks like. So what is an ID? Is it a number? Is it a string? How many characters? Things like that. Yeah. And what's again really good to mention is like, how do you start identifying what parts you can abstract into microservices? As I said, it's often a good case to look at what's already available, so you don't have to reinvent things. But it's often business logic, right? So like, what could be a potential system on its own? Users, often an easy one. Post/content. What systems can run in the background? So this is very dependent on your system. It could be. Sorry, I see my thing collapse a bit. but background processes could be very dependent. So it could be reporting, generation of certain things, analysis, and that often becomes multiple services, right? But you could also have a crawler, right? So every night you crawl a certain website to get data or to get posts or whatever it may be. So on, you decide what of these can become their own service. And when in doubt, you can always say, okay, let's make it a slightly bigger microservice. It becomes the background microservice. Over time, when you find, ooh, this process is very, very heavy, it kind of drains the whole system, we need to address it. You can then decide to like find the right tool for the job, scale it to its own little application, and make sure that's efficient. So don't feel like you need to come up with the perfect solution, because this is a big drawback of designing a microservice system, is that you overthink it, you want to make it perfect, but you'll find over time it's already better than what it was. You can scale it more individually, and yeah, that kind of works better as to what was there. Right. So with that said, I kind of want to go into the questions. So I think Aaron will have some questions prepared, but if any of you have anything, I would really love to answer those.
Hi, Chris. Yeah, actually, we do have a lot of questions for you. All right. So the
That's
first
good.
is, what are the benefits of using microservices to scale an application? So earlier you mentioned abstraction is one, and what, for example, what
Mhm.
does abstraction bring to the scalability of the application?
What does abstraction bring? I think the abstraction brings the possibility to either scale in the perfect way, right? So as mentioned, you're not bound to one set of scaling, right? So you can say the front end facing thing the user facing thing needs to scale to be highly available, right? So you can deploy these things to an edge worker or to multiple regions. That obviously helps. I think the biggest thing there is obviously cost and impact, and making it fast for the users. What else? The same with individual isolation, right? So service isolation, kind of like mentioned, finding the right database and even spooling up databases that work in sync can be beneficial for this type of architecture. You might find your high read-write database needs a server closer to the location that syncs back to a master database in the background once it gets resources. So things like that really become very important when
All right.
deciding to scale.
So next, what challenges can arise when using microservices to scale applications?
Yes, yeah, I do think I mentioned a couple in the presentation already. So, but to come back to this, there is a lot of benefits to microservices, but they can all turn into challenges if you do them wrong, or start feeling overwhelmed by them. So, the first one would be complexity. Um, systems can become complex to understand as a whole. It's mentioned in the bigger picture, but even the microservice, you might lose track of like why it was originally invented. What you often see with bigger companies that adopt this kind of structure is that they have a system. It might become redundant, but still live there, and then people wonder like, who's responsible for that? Why is it there? What does it do? Do we need it? So complexity is definitely a big challenge. The other one is coordination. So it becomes hard to say who's responsible for what, especially when we need to introduce new architecture, new microservice, right? So it becomes a question of like who will become the responsible person, what kind of language will they use, what framework will they use, what does it need to talk to. So coordination is very, very important and become a big challenge. The third one is consistency of the data. As mentioned, like every microservice should be responsible for its own data set. But in some cases, you might have data that comes from other systems, right? As mentioned, maybe you now made email address a required field for users, right? Which wasn't before. So if another system maybe is not aware of that, it can really impact your production system as a whole, or cause you to retroactively need to fix it. So yeah, I definitely found over time consistency of data needs a lot of, again, coordination to make sure that you have everything in place. The other one is when we talk about scaling, obviously it's a big pro that we can scale these things individually and into the right amount of server, the right space. But this adds a lot of overhead as well. It becomes very, very complicated. And that's obviously why we have a lot of people specialize in these things, like people experts in Kubernetes. It's because we want to design systems that are very, very complicated and need to scale automatically at the right time into the right type of scaling. So deployment and management of the system becomes a big challenge. And I think the last thing I like to mention here that becomes a challenge is testing the whole system. So often tests become very, very easy because we can say, okay, we've written certain tests for a user system. They all turn green. We tested some of the integration parts often by mocking data, but the whole system might still have an issue, right? So we might mock something in one place while they change something. So this is quite a big challenge to make sure that doesn't happen.
All right, thank you for that detailed answer. Yeah, so it's more like a management or organization challenge plus the data, right? All right,
Yeah,
so
exactly. I think it comes down to that as a whole. Yeah.
yep. Okay, so the next question is, what types of applications are best suited for microservices architecture? Like earlier you mentioned YouTube, right? So what are
Mm-hmm.
some other uh, types of applications that you can use microservices for?
Good question. Yeah, I think there's not like a particular right answer, right? Generally speaking, larger applications that have bloated a lot over time tend to be a good candidate. Um, yeah, it's often worthwhile checking if your application clearly shows parts that can be abstracted. So you look at certain systems and think, why is like the analytics like inside the system that can easily be a self-running system, which would be a great indication. But another one could be applications that need rapid change, right? So that need quick improvements over time. So this is often the user-facing things, like you want to experiment with new designs that work better, marketing kind of things that need to change. So that you kind of want to abstract from whatever the business logic behind it might be. Another one that is often what you see in a YouTube, Netflix, Facebook, Twitter, is that they need to be highly available. People expect those things to load in less than a millisecond from wherever they are in the world. It needs to be quick. There needs to be no lag because they'll stop using it. And that's often when you really, really need to adapt a microservice, because with a big loaded system, you'll always have that background lag. So they often choose to go specifically the route of microservice to make sure their user-facing systems are available. And yeah, this is often also refer to anything that needs to run on cloud edge kind of functions. That's often created as a small thing to do one very specific action that you can abstract. And those are often the small elements to a complete system. So luckily, something we see happening a lot, where if you take web shops, for instance, they like to abstract the cart system as a microservice, so they can kind of use some like real-time updates to that, while it still can check like background if they have stock, whatever it may be. So yeah, it's cool to see those kind of options these days in development, where we don't have to rely on a full-blown system that does too many things for us.
Yep, I agree. It's great. Okay, so how about the tools? Do you have any tools that you can recommend to help developers manage microservices? What tools are available?
Yeah, there are a ton of tools available, and they vary from framework agnostic tools, right, to set up a good structured system. So there are a lot of tools dependent on what language or framework you pick that can help you set up like a good gateway or API system. So I won't really go into those. But then there are a lot of container orchestration tools. So you can think about like Kubernetes, for instance, a really good example of something that helps you orchestrate how you want to scale in the most efficient way. And another tool set is kind of logging and monitoring tools, right? So you can think about like Prometheus, Grafana, that can really help you to better monitor your complete system and log issues, so you can actually trace them back to the error, which microservice caused the error. Then we have some CI/CD tools, so that can really help us with automating deployments, running tests, making sure failed tests don't get deployed, things like that. So you might know Jenkins, Circle CI, and there's a ton more. Depending on what your company uses, it might be different. And then I think one of the biggest tools is cloud hosting, right? So whatever you may use, it may be something like on AWS, it might be Google Cloud, might be something else. All those cloud hosting providers, they have a lot of services. So we, for instance, use Google Cloud, and they have perfect logging and tracing options. They have error reporting, billing alerts, scaling options based on what your Kubernetes provides. They have perfect event systems in place. So they often have the tools you need for microservice architecture, which is great to read up about. They often also do free courses on like designing microservice with their system. So definitely worth checking that out.
All right, that's great. Thank you for your tips. Next question. How can developers ensure that their microservices are well tested and robust?
Yeah, I think this is one of the things where microservices actually thrive, because you can write different test case, like different test types for different microservice, right? So depending on the system, you can think about unit testing for your individual component systems, but you can add integration tests to test the different interactions between the microservices, and you can do some functional tests. I think my camera just focused. You can write some functional tests locally or in staging environments. You can do like proper manual tests. A very important one when you design microservices is that you introduce load testing, right? With one big system, it's very easy to notice like the whole system got slow. With microservices, it may not be. So one of your background workers may be stuck because it's doing too much, it's too big, but you might not be aware because it like only runs every night, and every night it happens, so you don't really know about it. So I think it becomes very important to make sure that your scaling works, that it works by putting load on these actual things. Then, like mentioned, very important to keep monitoring your application. It could be all your tests are succeeding, but the whole system has one issue because of a certain reason, which might not show in the individual test, but the system in the whole might have that. And definitely, like I said, make use of the tools, like Circle CI that does all these things for you before it even deploys, so you can capture it early on.
Great. Okay, so the next question that we have here is, yeah, you mentioned that one of the problems of using microservices is handling data consistency between different microservices. So do you have any advice for how developers should handle that?
Yeah, I think as mentioned a couple times, it's very, very important that you define a source of truth for a specific subset of data. So you shouldn't replicate data to another microservice. So your user system should be the only database that has users. Like you shouldn't replicate a user into another database because you need his name, for instance, right? It's way better to fetch the data when you need it and use it at the time, or send it over an event stream when you need to do something with this data. I think that's the number one, to make sure that there's only one source of truth for data. And a good thing to help with that, obviously, is the event-driven architecture. But there are a couple ways where you can add consistency protocols, basically. There are various ones. Won't go into all the details. You can look it up after the talk. Also really depends on how big you make your system, but there's a lot of protocols that you can use that can help you to make sure data is validated in the right way.
All right, thank you. We still have a few questions. Are you still okay? All right,
I'm
so
so
the
good. I'm so good.
next one is, what approaches should developers use for deploying microservices? So are there strategies for deploying them, or?
Yeah, I think the first thing you want to do is to start with containerization, right? So start using Docker for your individual applications. So make sure they can run in a container. And why I say that is because after that, we'll start looking at orchestration, right? So we start adding Kubernetes or Nomad or whatever you use to make sure they work as a whole system. And we personally start by doing that on a local environment, so Docker desktop, for instance, perfect example, can run Kubernetes, so you can actually try your whole system locally. And after that, you start deploying that to often a cloud service. Most of them can work with any orchestration tool. So the big benefit there is that you already written it for your local thing, and you can just mimic it on any system, right? So even if you start out AWS and then decide to go to Google, whatever, it just works because your orchestration didn't change. So they might have a different implementation of it, but you don't need to rechange your whole system. So I think that's great steps to start. Start with containerization and then orchestration.
All right, thank you. Next, how can developers ensure their microservices are secure?
Very important topic, and I think microservices are they thrive on security by design, right? So we should really set up the system to not expose anything we don't need. So this is one of the big benefits, is that you abstracted these things, right? So you can say your private images that are background workers, they don't even need to be exposed to public ports, right? So they can run on the server. No one can reach them by design, obviously, unless your cloud hosting gets hacked in a bad way. But by design, they are secure. And then there are some extra things we can do, which obviously everything needs to be HTTPS these days. And when you interact, because like I mentioned, often microservices start introducing an API in between all the services. Make sure that you always use secure tokens, even if you're addressing an internal system, right? So maybe you are chatting to your internal microsystem. You might think, it's fine. I'm just chatting from this guy to this guy. Still validate like a secure token that you send, so you know people can't mock the connection. Then make sure all your data is encrypted if you're sending it over any protocol. Validate all inputs, trust nobody. I think that's very important. Even though you think like, okay, no, but my system is sending data, still validate it, because maybe someone somehow got a weird email address. I don't know, you never know. Whatever can happen, so validate all the inputs. And continuous security testing, I think, is very important. So perform regular security tests on find vulnerabilities and weaknesses in your system. This is often like a broad thing that needs to happen, right? It's not one person, not one team, it's the whole company responsible for that. And yeah, use tools. There are a lot of tools here as well. So for instance, there are dependency scanning tools like Dependabot, for instance. It's really great at finding vulnerable issues in certain software. It will notify you. Half the time it will fix it for you just by updating the dependency. And definitely a great approach to making sure your application is secure.
All right, thank you. Last question. What strategies should developers use for monitoring the performance of microservices?
I think when it comes to performance, it's important to use good logging and monitoring architecture. This is very often it's the case, depending on your hosting, cloud hosting, to make sure that they have these systems. Why I say that is because you might have internal logging, but it needs to have one protocol, right? So for instance, we use the same logging output you can use in Google Cloud, and it will all log in one big batch. So every microservice gets like in the same logging system. Then you can filter out per microservice which one you want to see. Why that's important is because something might happen here, might impact the other microservice. You might not have a direct impact on it, but with these systems, you can kind of see, okay, this happened. Here's the trace ID. We can find it. We know the timing. We know this. So it's easier to find gaps in the system. Yeah. Also, take load testing is very important here. Make sure that your system is up for a big load, right? So if it's user facing, especially, you might get all of a sudden a lot of people join at the same time or wanting to do something. Your system needs to be prepared for that. I think that also is very important when you consider performance of a microservice. Obviously, set up the auto scaling in your orchestration, right? Make sure that certain apps that need to can auto scale, right? So it's up to you as the designer of the system to ensure that the system can scale. And you can obviously set limits to it for specific cost reasons. I think the last thing I want to add is dashboards and alerts. So you might want to add alerts if certain systems go down or are unreachable, give errors, and some dashboards maybe to see anomalies, lost to see any
That's all right.
weird things happening really in your
Anomalies, yeah.
system, right? So Yes. So we often use dashboards to quickly see if certain sources are no longer producing posts or whatever it may be. So it could be on our side, could be on their side, but at least we know about it. It's not a particularly quick issue, but it is something that needs addressing regardless. So yeah.
All right, thank you. That's it for the Q&A. Would you like to add anything else?
No, I think my main thing is someone who got introduced to microservices from a background of not working with them is to don't try to overdo it, right? Don't try to learn the
Yeah.
whole thing all at once. Start small, work your way up, start exploring how you can contribute and understand the whole system. And if you are the one designing it, don't expect the world from it, right? Start small. I think that's the main thing.
All right, thank you, Chris, for the detailed presentation. All right.
Cool. Thank you very much for having me. Yeah, it really was fun talking about this. I hope you enjoyed it. Yeah, thanks again for
Yeah,
having me.
thank you, Chris.